You're watching a free sample video from Teacher's Test Prep. For videos like this one covering every area of your exam, visit us today at www.teacherstestprep.com.
We're going to spend some time talking about the unit circle, and the unit circle is called that because we're talking about a circle with radius length 1 unit. It might be 1 inch, might be 1 mile. It's just a circle with radius 1 unit. It's called the unit circle. So first, there are 2 pi radians in a circle, and we're going to talk about more what that means and how you convert between degrees and radians. So I'm going to draw on my board a circle, and we're going to talk about what a radian is in relation to the radius. So here's a circle with radius 1. I'm just going to call it r for now, whatever that radius is. And if we want to think about the formulas we already know for circumference, or arc length, circumference around the outside of the circle, I would say the circumference of the circle is equal to 2 pi r. But if I'm saying my radius is equal to 1, then my circumference is just going to be 2 times pi times 1. So let's think about what that means first. You know that the mathematical constant pi is approximately 3.14, so the circumference of this circle is about twice that much, 6.28-ish. And let's see what that looks like. It's 6.28 radiuses. In our case, the radius is 1. Let me show you, if I could measure this amount, this radius, and lay it around the arc, I would have about 1 radius, 2 radiuses, 3 radiuses, 4 radiuses, 5 radiuses, 6 and a little bit more. This is what a radian is. A radian is just 6.28 of my radius is around the arc length. So a radian is a measure of arc length. It also goes along with the idea we've talked about how a central angle, if this angle here is x degrees, this arc length could be called x degrees. But usually we call it in terms of an arc length with radians. So that's kind of a little bit about the relationship between degrees and radians, trying to answer the question, what is a radian? So any angle could be named either in its degrees amount or in its radian or arc length amount. To convert between radians and degrees, we multiply by 180 divided by pi, and to convert from degrees to radians, we multiply by the reciprocal, pi over 180. Radians are a natural development related to the circumference of a circle, as we saw on the board, and we simplify the calculations using radians. The nice thing about radians is your numbers are usually smaller. Instead of using, let's say, 60 degrees, you can use the radians number pi over 3, and then do your work with fractions instead of having to use a calculator. In radians, the arc length around around a circle, the distance along an arc, is the radius times theta, where theta is that central angle that the arc is defined by. Angles are named by their measure moving in the positive or counterclockwise direction. A negative angle has the same measure, but in the clockwise direction. So we're going to look at that on the board as well. If on the xy plane I wanted to consider this angle here, theta, it's approximately 30 degrees. I'm just going to say, let's say this is 30 degrees. And I call it 30 degrees because I'm moving in the counterclockwise direction. Now if I wanted to call this angle here, that's swept right here, still 30 degrees. I'm trying to show it's the same width of angle, but now I'm going in the negative direction. This theta would have a measure of negative 30 degrees. Now keep in mind, I'm still talking about this angle here. If I wanted to name the angle around here, that would be something different. That angle that I just drew, this one that's larger than 180 plus another 90, is 360 all the way around. This bit is 330 degrees, positive, because it's in the counterclockwise direction. We call that angle coterminal with negative 30. They share this terminal ray right here. They both start here on the x-axis, and that's generally where we place angles in the xy plane. Negative 30 is swept in the clockwise direction. Positive 330 is swept in the counterclockwise direction, and they share a terminal side. We call those coterminal angles. The unit circle displays points on a circle with radius 1. Each point xy is therefore the cosine of the theta and the sine of theta. And some of the key values that we're going to be looking at are 30 degrees, 45, and 60 degrees, which could also be named in radians, pi over 6, pi over 4, and pi over 3. we're going to talk about how the sine and cosine relate with what we've just talked about in terms of a point on the unit circle. If I place a circle at the origin, we're going to be talking about a point on the unit circle where it has radius number r, radius value r, vertical change as always is y, horizontal change is x. So this point right here, we used to call it x comma y, but we're going to talk about how we can name that in terms of sine and cosine of this angle here. Keep in mind that sine of an angle is defined as the ratio of opposite side to hypotenuse. So sine of this angle is equal to opposite over hypotenuse, and cosine of this angle is equal to adjacent over hypotenuse. And if my radius is 1, if I'm talking about the unit circle, then these denominators are just 1. Cosine is equal to x and sine is equal to y. So if I take this circle and make it the unit circle, instead of being a coordinate x comma y, I'm going to make it cosine of my angle comma sine of my angle. And that's what a lot of the coordinates, or that's exactly what the coordinates on the unit circle are referring to, and how you can relate them to the central angle. One last thing before we look at the next slide is that this central angle will always be placed here on the xy coordinate plane. It will always have one side horizontal. It'll always start from the positive x-axis. If we go through and look at the positive and negative nature, or the sign, S-I-G-N, of each point on the unit circle, in the first quadrant we'll see sine is positive in the first and second quadrants, and we'll see cosine is positive in the first and fourth quadrants. You can relate that to x and y if you want to. We've just discussed how cosine is like x. So for the x positives, when x or cosine is positives, that's quadrant 1 and 4. And places where sine is positive or where y is positive is quadrants 1 and 2. The next slide shows the unit circle in all of its glory. This is a slide that you're going to want to be able to recreate with your eyes closed. Try to set aside your PowerPoint and get to where you are in your math fluency, that you can draw this from scratch. This unit circle, where each xy coordinate pair is the cosine of an angle comma sine of an angle, shows essentially the fundamental basis of trigonometry. You see how 30 degrees, which is also called pi over 6, has a cosine value of root 3 over 2 and a sine value of 1/2. You can see how cosine of 45 degrees, which is also called pi over 4 radians, has a cosine of root 2 over 2 and a sine of root 2 over 2, and continuing around the circle. You should be able to also connect this with the sinusoidal pattern of trigonometry graphs. You can imagine how, or you can see in the unit circle, how cosine starts at 1. When our angle is 0 degrees, our cosine starts at 1, and then it decreases, and then it comes back up. You can see that in the x-coordinates. It starts at 1, x-coordinates come down to 0 at 90 degrees or pi over 2, and then comes back up to 1 again. So moving back and forth between the unit circle and the graphs of sine and cosine function is a key skill to understanding the unit circle and also trigonometry.
We hope you found this free Teacher's Test Prep sample video helpful. For more videos like this one covering all the subject matter and strategy you need to pass your exam, visit us today at www.teacherstestprep.com.